Dear students, Namaskar. Hope you all are fine. Student, today we are going to study grade 8 subject mathematics lesson 2 whole numbers. And today is the second class of whole numbers. In previous class, we have learnt that how to convert binary number into decimal number and decimal number into binary number. And we also discussed that in decimal number system, there are 10 digits 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Whereas in binary number, there are only 2 digits 0 and 1. The base of binary number is 2. When base is written 2, then we understand that it is binary number. But today we are going to discuss about quinary number system, and this number system is very much similar to binary number system. But before to start quinary number system, let's do one activity. What is the activity? The numbers from 0 to 20 in decimal number system are given in the table below. You can see in this table the numbers from 0 to 20 in the decimal number system are given. Circle the numbers that are made up of using 0, 1, 2, 3 and 4. So we are given the numbers from 0 to 20 and we have to circle the numbers that are made of using the digits 0, 1, 2, 3 and 4. Can you circle? Which one will be the first number? Yes, you are correct, 0. The next, 1, then 2, 3, 4, because we have to circle the numbers that are made up of using 0, 1, 2, 3 and 4. Then can we circle 5? No. Now what will be the next digit? Can you guess? That are made up of 0, 1, 2, 3 and 4. Yes, you are correct. Now 10, then 11, then 12, 13, 14. Can we circle 15? No. Why we cannot circle 15? Because we have to circle the numbers that are made up of using 0, 1, 2, 3 and 4. But in 15, we have 1 and 5, so we cannot circle. Now what will be the next digit? Can you guess? Yes, 20. So these are the numbers which are made up of using 0, 1, 2, 3 and 4. Now we are writing here quinary number system. In quinary number system, we have 0 and in decimal number system also its value is 0. Whereas in quinary number system, if we have 1, then in decimal number system also its value is 1. 2, same 2 value, 3, same value, 4 also same value. But if we have 1, 0, we cannot read it 10 in quinary number system. We read it 1, 0. Then 1, 0 represents 5 of decimal number system. Similarly, 1, 1 of quinary number system represents 6. Similarly, 1, 2 represents 7 of decimal number system. 1, 3 represents 8 of decimal number system. 1, 4 represents 9 of decimal number system. And 2, 0 represents 10 of decimal number system. So on the basis of this activity, what we say in decimal number system or base 10, but generally we do not write base 10 because if no base is written, then we understand it is decimal number system. So we use 10 digits. In decimal number system, we use 10 digits. And what are the 10 digits? We have already discussed earlier. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Whereas in quinary number system, we use only 5 digits. In quinary number system, we use only 5 digits. What are the 5 digits? 0, 1, 2, 3 and 4. And we studied in earlier class, in binary number system, we use only 2 digits. What are that 2 digits? Can you tell me? Yes, you are correct, 0 and 1. And we count the numbers in quinary number system as 0, 1, 2, 3, 4. Then we do not read it 10 in quinary number system, we read it 1, 0. Similarly, 1, 1, 1, 2, 1, 3, 1, 4, 20 as we have circled here. Now we are going to discuss quinary number system and its expansion. You studied that in decimal number system we expand it by arranging in the groups of 10, 10, 10. We arrange it in the power of 10. Similarly, in binary number system, we arrange in the group of 2 and we arrange it in the power of 2. Similarly, in quinary number system, we have to arrange it in the group of 5. For an example, here also we are doing one activity. Suppose we have 27 pens, and if we have to arrange 27 pens in the groups of 5 pens, how can we arrange? Look here. These are 5 pens, one group, another group also 5 pens, in third group also 5 pens, in fourth group also 5 pens, and in fifth group also 5 pens. So altogether how many pens we have now? 5 5s are 25 pens. Now how many pens are left? 2 pens are left. So we arrange 27 like 5 plus 5 plus 5 plus 5 plus 5 plus 2. 5 plus 5, how many times 5? Can you count it? 1, 2, 3, 4, 5. So we can write 5 times 5, whereas we have 2 only 1 times. So we can write 5 times 5 plus 2 times 1. 5 times 5 can be written as 1 into 5 square, because 5 times 5 is 25, 5 square is also 25, 2 as above, and 5 to the power 0, 1, because we know that anything to the power 0 equals to 1 except 0, because 0 to the power 0 is not 1. So it can be written like this. Again, it can be written as, we have 5 to the power 2, then directly we have 5 to the power 0. We do not have 5 to the power 1, so we write 0 times 5 to the power 1, because 0 times 5 to the power 1 becomes 0 to get the pattern. So 1 times 5 square plus 0 times 5 to the power 1 plus 2 times 5 to the power 0. In this way, we can arrange 27 pens in the groups of 5. And why we have arranged in the group of 5? Because we have discussed in earlier slide that in quinary number system we have 5 digits, that's why we have arranged in the group of 5. In binary number system we have only 2 digits, 0 and 1, that's why we arrange there in the group of 2. Now, place value table of decimal number system, we already know. This is the place value table of decimal number system. And in decimal number system, we have base 10, so we multiply it by 10. 1 tens are 10, 10 tens are 100, 100 tens are 1000. And we have written same thing here in number. 1 can be written as 10 to the power 0, because anything to the power 0 equals to 1 except 0. 10 can be written as 10 to the power 1, 100 can be written as 10 square, similarly 1000 can be written as 10 cube. And in place value table, we have taken 1256. Now we discuss the place value table of quinary number system. In place value table of decimal number system, we have multiplied by 10, 1 tens are 10, 10 tens are 100, 100 tens are 1000, because base is 10. Similarly, in binary number system, base is 2. So in place value table, we write 1, then 2, then 4, then 8. Similarly, can you guess what shall we write in the place value table of quinary number system? Yes, your guess is correct. We multiply it by 5. Look here. 1, 5, 5 5s are 25, 25 5s are 125. Why we have multiplied by 5? Because in quinary number system we have base 5, so we have multiplied it by 5. In binary number system base is 2, so multiply it by 2. So the calculation of quinary number system is exactly like the calculation of binary number system that we discussed in earlier classes. But in binary number system, we have only 2 digits, 0 and 1. And in quinary number system, we have 5 digits, 0, 1, 2, 3 and 4. So we multiply it by 5. Otherwise, remaining things are same. 1 can be written as 5 to the power 0. 5 can be written as 5 to the power 1. And 25 can be written as 5 square. Similarly, 125 can be written as 5 cube. and here in quinary number system we have taken 1340. Now, firstly we are writing this decimal number system 1256 in expanded form. So 1256 we are writing in expanded form. So we have 1 times 1000 here, plus 2 times 100, then 5 times 10, then 6 times 1 we have written from the table. So 1 times 1000 becomes 1 times 1000, 1000 can be written as 10 cube, 2 times 100 can be written as 10 square, and similarly 10 can be written as 10 to the power 1, and 1 can be written as 10 to the power 0. In the same way, now we are writing 1340 of quinary number system in expanded form. So how can we write? Look here, we have 1 times 125, 3 times 25, 4 times 5, and 0 times 1, we are writing the same. 1 times 125, exactly like decimal number system, or you may compare it with binary number system. 1 times 125, 3 times 25, 4 times 5, and 0 times 1. 125 can be written as 5 cube, 3 as above, 25 can be written as 5 square, 5 can be written as 5 to the power 1, so 4 times 5 to the power 1, 0 times 1 can be written as 5 to the power 0, because anything to the power 0 equals to 1 except 0. So on the basis of this activity, now what we can say, similar to how we write in decimal number system, in the place value table as 1, 10, 100, 1000, or we may write 1 means 10 to the power 0, 10 means 10 to the power 1, 100 means 10 square, 1000 means 10 cube, and so on. In the place value table of quinary number system, we write 1, 5 multiplied by 5 because base is 5, and you have already seen in binary number system we multiply it by 2. So 1, 5, 5 5s are 25, 25 5s are 125. Similarly, 125s are 625, or in the form of power, 1 can be written as 5 to the power 0, 5 can be written as 5 to the power 1, 25 can be written as 5 square. Similarly, 125 can be written as 5 cube, and 625 can be written as 5 to the power 4. So we express the quinary number system as a power of 5. We express the decimal number system in the power of 10. Similarly, we express the binary number system in the power of 2. So a number from quinary number system is explained using suffix 5. Suffix 5 means base 5. For example, 124, here base is 5 or suffix is 5. 1340, here base is 5 or suffix is 5. In binary number system, we write suffix 2. Now we are going to study how to convert quinary number into decimal number. It is exactly like how to convert binary number into decimal number. Look here. Conversion from quinary number system into decimal number system. In quinary number system, we have 142013. Here base is 5 because it represents quinary number system. Is shown in the place value table. We know in base 10, 1, 5 multiplied by 5 because base is 5 in quinary number system. 25 5s are 125. Then similarly 125 5s are 625, and if you multiply 625 by 5, it becomes 3125. And 1 can be written as 5 to the power 0, 5 can be written as 5 to the power 1, 25 can be written as 5 square. Similarly 125 can be written as 5 cube, and 625 can be written as 5 to the power 4. Similarly 3125 can be written as 5 to the power 5. And what is our number? 142013. Now we are writing 142013 of quinary number in expanded form in the power of 5. So it can be written as 1 into 5 to the power 5. You can see here 4 into 5 to the power 4, 2 into 5 cube, 0 into 5 square, 1 into 5 to the power 1, 3 into 5 to the power 0. Again, 5 to the power 5 means 3125. So 1 into 3125. Similarly, 4 into 5 to the power 4 means 625. So 4 into or 4 times 625. Similarly, 2 times 5 cube means 125. Similarly, 0 times 5 square means 25. 1 times 5 to the power 1 means 5, plus 3 times 5 to the power 0 means 1. Now look here, now writing in decimal number system, we have to multiply this. So 1 times 3125 becomes 3125. Similarly, 4 times 625 becomes, use your calculator, 4 times 625 becomes 2500. Similarly, 2 times 125 becomes 250. 0 times 25 becomes 0. 1 times 5 becomes 5. 1 5 is 5. And 3 times 1 becomes 3. Now use your calculator and add this. How much have you got? Yes, you are correct. 5883. So we do not write base 10 in decimal number system, because if no base is written, then what we have to understand, base is 10, and as it is understood just by 5883. So quinary number 142013 is equal to 5883 of decimal number system. Now can you tell me what is the difference in binary number system conversion and quinary number system conversion? Yes, you are correct. Here we have written in the power of 5, whereas in binary number system we have written in the power of 2. Remaining calculation technique is similar. So on the basis of this conversion, now what can we say? To convert the quinary number system into decimal number system, we have to write the given number in expanded form in the power of 5 and then simplify. We have to write the given number in expanded form in the power of 5, then simplify. In binary number system, we have to write the given number in the power of 2. Here we have written in the power of 5, because in quinary number system, base is 5 and there are 5 digits. So on the basis of this much discussion, now can we discuss some more numbers to convert quinary number into decimal number? Okay, ready? Look here. What is written here? Convert the following numbers from quinary number system to the decimal number system. We are given some numbers from quinary number system, because in each number you have seen here base is 5. So these are the numbers of quinary number system, and we have to convert it into decimal number system. So how can we convert? Yes, can we do this first question on the board? 34 base is 5. Okay, look here. A number question is 34 and its base is 5. Base is 5 means, base is 5 means it is the number of quinary number system, and we have to convert it into decimal number system. So we have already discussed. Look here, 3 times, how many digits are after 3? 1 digit. So we write 5 to the power 1 plus 4 times, how many digits are after 4? No digits. So we write 5 to the power 0. We express in the power of 5. 3 times 5 to the power 1 means 5, plus 4 times 5 to the power 0 means 1. So 3 5s are 15 plus 4 1s are 4. If you add these two, it will be 19. So 34 of quinary number system is equal to 19 of decimal number system. Let's check the same calculation here. 34, same we have written 3 times 5 to the power 1, because after 3 there is only one digit, so 5 to the power 1. If there will be 2 digits, we write 5 to the power 2. If after 3 there will be 5 digits, we write 5 to the power 5 and so on. Similarly, plus 4 times and there is no digit after 4, so we write 5 to the power 0. 3 times 5 to the power 1 means 5, plus 4 times 5 to the power 0 means 1. 3 5s are 15, plus 4 1s are 4. So 15 plus 4 is 19, that we discussed on the board also. Similarly, now we are going to discuss B number question, which is 343 base 5. Can you tell me what shall we write? Yes, you are correct. There are 2 digits after 3, 4 and 3. So we write 3 times 5 to the power 2 because there are 2 digits, plus 4 times 5 to the power 1 because after 4 there is only 1 digit, plus 3 times 5 to the power 0 because after this last 3 there is no digit, and we write the same here, 3 times, and after this 3 how many digits are here? 2 digits, 4 and 3, so 5 to the power 2 plus 4 times, and after this 4 how many digits are here? 1, so 5 to the power 1 plus 3 times, and after this 3 there is no digit, so we write 5 to the power 0. We know that 5 square is 25, so 3 times 25 plus 4 times 5 to the power 1 means 5 plus 3 times 5 to the power 0 means 1. 3 times 25 is 75, whereas 4 times 5 is 20 plus 3 times 1 is 3. Use your calculator, add this and tell me how much have you got. Yes, you are correct. It is 98 because 75 plus 20 becomes 95. 95 plus 3, 98. Similarly, we discuss now C number question, which contains 4 digits, 2014. Firstly, we have discussed in 2 digits, then we have discussed in 3 digits, now in 4 digits. So can you guess how can we change this 2014 of quinary number system into decimal number system? Yes, you are correct. 2 times, and after 2 how many digits are here? 3, 1, 2, 3. So 2 times 5 to the power 3 plus 0 times, and after this 0 there are only 2 digits, 1 and 4. So 0 times 5 to the power 2. Similarly, this 1 times, and after this 1 there is only 1 digit. So 1 times 5 to the power 1 plus 4 times, and after this 4 there is no digit. So we write 5 to the power 0. 5 cube is how much? Yes, you are correct, 125. So 2 times 5 cube means 125 plus 0 times 5 square means 25 plus 1 times 5 to the power 1 means 5 plus 4 times 5 to the power 0 means 1. So 2 times 125 is 250. 0 times 25 is 0 plus 1 times 5 is 5. Similarly, 4 times 1 is 4. Now use your calculator and tell me how much have you got. Yes, you are correct, 259. So 2014 of quinary number system is equals to 259. Dear students, in A number question we have taken 2 digits quinary number system, whereas in B number question we have taken 3 digits quinary number system. In C number question we have taken 4 digits quinary number system, whereas in D number there are how many digits? Can you count? 1, 2, 3, 4, 5. So 5 digits quinary number system. And how can we convert it into decimal number system? Yes, so can we discuss D number? Okay, move to D number. How can we write? How many digits are here after 1? Count 1, 2, 3, 4. So 1 times we write 5 to the power 4. Similarly, how many digits are after 2? 1, 2, 3. So 2 times 5 to the power 3. Similarly, after this 3, how many digits are here? 1 and 2. So 3 times 5 to the power 2. Similarly, after this 0, how many digits are here? Only 1. So 0 times 5 to the power 1 plus 4 times, and there is no digit after 4. So 4 times 5 to the power 0. 5 to the power 4 is how much? Use your calculator and tell me. Yes, you are correct, 625. So 1 times 625. Similarly, 5 cube is 125. So 2 times 125 plus 3 times 5 square means 25 plus 0 times 5 to the power 1 means 5 plus 4 times 5 to the power 0 means 1. Now again use your calculator. 1 times 625 is 625, whereas multiply 2 and 125 you will get 250. Similarly, if you multiply 3 and 25 you will get 75, and 0 times 5 is 0 and 4 times 1 is 4. Now use your calculator and tell me how much have you got. Yes, you are correct. You have got 954. So 12304 of quinary number system is equals to 954 of decimal number system. So up to now we have discussed how to convert quinary number into decimal number system. Now question arises, how can we convert decimal number into quinary number system? Do you have any idea? Yes, your guess is correct, because in binary number system, to convert decimal number into binary number, we divide it by 2 because base is 2. But in quinary number system, base is 5. So instead of dividing 2 in binary number system, in quinary number system, we divide it by 5. So look here now, conversion from decimal number system into quinary number system. And we have taken one number from decimal number system, which is 432. And 432 of decimal number system, how can we convert into quinary number system? So firstly, we arrange 432 as the sum of power of 5. So how can we write? 432 can be written as sum of power of 5. So 5 cube means 125, whereas 5 to the power 4 means 625. And since our number is less than 625, so we cannot write 5 cube or 5 to the power 4. We cannot write 5 to the power 4 because 5 to the power 4 means 625 and our number is less than 625. So we have to arrange it in terms of 5 cube, which is 125. So 125 plus 125 plus 125, 3 times 125, which is 375, plus 25 plus 25. So in 375, 25 plus 25 becomes 50. So in 375, if we add 50, then it becomes 425. But again we need 432. So plus 5, 425 plus 5 becomes 430 plus 2. So we have arranged it in the power of 2. But again question arises, sir, 2 is not in the power of 5. Yes, we know 2 is not in the power of 5, but 2 can be written as 2 times 5 to the power 0, because anything to the power 0 except 0 is 1. That's why we have written like this. Now look here, we have how many times 125? 3 times 125. Similarly, 2 times 25, 1 times 5 and 2 times 1. So 125 can be written as, now look the place value of quinary number system, you know, 5 to the power 0, 5 to the power 1, 5 to the power 2, 5 to the power 3. So 3 times 125, which is 5 cube, 2 times 25, which is 5 square, and 1 times 5 to the power 1, which is 5, and 2 times 5 to the power 0, 5 to the power 0 means 1. So this becomes 3 times 5 cube plus 2 times 5 square plus 1 times 5 to the power 1 plus 2 times 5 to the power 0. Now this will give us how much? 3, you can see here 3, 2, 1, 2. So 3, 2, 1, 2. So 3, 2, 1, 2 and base is 5 is equal to 432 of decimal number system. Now again question arises, sir, can we solve this question by other method? Of course, we can solve this question by other method also. In binary number system, base is 2, so we divide it by 2. But in quinary number system, base is 5. So we can convert decimal number dividing it by 5, exactly like the calculation of decimal number to binary number. But instead of dividing 2, we have to divide it by 5. Look here. So we divide it by 5. So 86 5s are 430. 432 minus 430 becomes 2. So remainder is 2. Similarly, again we divide it by 5. Then 17 5s are 85. 86 minus 85 becomes 1. So we write remainder here 1. Similarly, we divide 17 by 5. Then 5 3s are 15. 17 minus 15, 2. So we write remainder 2. Similarly, 5 zeros are 0. So 3 minus 0 is 3. So we write remainder 3. And we write the remainder in reverse order. Then it will give us 3212, exactly same number. 432 of decimal number system is equals to 3212 of quinary number system. So exactly calculation of decimal number to binary number. It is exactly like the calculation of decimal number to binary number. But to convert a decimal number into binary number, we divide it by 2. And here base is 5, so we divide it by 5. And we keep dividing unless and until we get here 0. Now we are going to discuss some more questions. Look here. 26 of quinary number system. How can we convert 26 of decimal number system to quinary number system? Same, divide 26 by 5. 5 5s are 25. 26 minus 25, then remainder is 1. We write remainder here 1. Again, divide 5 by 5, then 5 1s are 5. 5 1s are 5, then 5 minus 5 becomes 0. So remainder is 0. Again, divide this 1 by 5. 5 zeros are 0. Then 1 minus 0 becomes 1. So remainder is 1. And I told you in previous slide also, we keep dividing unless and until we are not getting here 0. So we have got 0, so we have to stop it. Now write the remainder in reverse order. Then 26 of decimal number system is equals to 101 of quinary number system. Similarly, we discuss B number, which is 194 of decimal number system, and we have to convert it into quinary number system. So exactly similar to the calculation of A, we divide it by 5. Then how much we got? 38. 38 5s are becomes 190. So from 194, if we subtract 190, remainder is 4. Similarly, again divide this 38 by 5, then 5 7s are 35. 38 minus 35 becomes 3, so remainder 3 here. Similarly, divide this 7 by 5, then 5 1s are 5. 7 minus 5 becomes 2, so remainder is 2. And divide this 1 also by 5, then 5 zeros are 0. So 1 minus 0 becomes 1, so remainder is 1. We keep dividing unless and until you are not getting here 0. Now write the remainder in reverse order. Then this becomes 194 of decimal number system is equals to 1, 2, 3, 4 of quinary number system. Similarly, we discuss C number question, which is 1128 of decimal number system, and we are going to convert it into quinary number system. So exactly like A and B, we divide it by 5. So divide 1128 by 5. Use your calculator. How much have you got? Yes, 225 5s are. 225 5s are. Multiply 225 by 5. Then you will get 1125. From 1128, if you subtract 1125, then remainder is 3. Similarly, divide this 225 again by 5. Then how much have you got? Yes, you are correct, 45. 45 5s are exactly 225. So from 225, if we subtract 225, then remainder is 0. Now again divide this 45 by 5. Then how much? Yes, you are correct. 5 9s are 45. Again 5 9s are 45 minus 45, remainder is 0. Now divide this 9 by 5. Then 5 1s are 5. 9 minus 5 becomes 4. So remainder is 4. Now divide this 1 by 5. Then 5 zeros are 0. And 1 minus 0 becomes 1. So remainder is 1. And we have discussed many times, we have to keep dividing unless and until we are not getting here 0. So we have got 0, means we have to stop. And now we have to write the remainder in reverse order. So 1128 of decimal number system is equals to 14003 of quinary number system. Dear students, in today's class, we have discussed that in quinary number system, there are 5 digits, 0, 1, 2, 3 and 4. And we represent quinary number by writing in suffix or writing in base by 5. And then we discuss how to convert quinary number into decimal number. After that, we discuss how to convert decimal number into quinary number. Hope you have understood each and everything that we have discussed. Please do the remaining question of exercise and show to your respective teacher. Thank you very much. Namaste.